This is the video for test 2 review, questions 6 through 10. Question 6 says, does this function have a minimum or maximum value? And the way that we know that is that we look at the degree. This is a 2 degree, so it's 3x to the 2, so that's the second degree, which means that's going to be a parabola. And parabolas either face up or face down. In this case, because that leading term is positive, it means it's going to face upward, so therefore it will have a minimum value. It says, what is the function's minimum or maximum value? So when you're dealing with parabolas, to find the point, because this is a point that has an x and a y coordinate, and the formula is x equals negative b over 2a. So in this case, our b is a negative 24, and our a is a 3. So if I simplify this, I get 24 over 6, which is 4. And that gives me the x value of that point. If I want to find the y value, I would need to plug it back into this function. So I want to know what it is when I put a 4 in there. So that's 3 times 4 squared minus 24 times 4 plus 49. So that's 16 times 3, which is 48, minus this is 96 plus 49. So I get negative 48 plus 49, which is 1. So what I found there was the y coordinate of that minimum point. So that minimum point happens to be 4, 1. And what's a little bit tricky about these questions is determining which piece of the point they're asking about. So when it says, what is the function's minimum or maximum value? A minimum or maximum has to do with height. So that would be the y coordinate. So that would be a 1. And then it says, where does the minimum or maximum occur? It occurs, the where is the x coordinate. So that occurs at 4. And then my answer for this was minimum. Let's move along to question number 7. So 7 says, suppose the polynomial function f is defined as, and it gives the function here, 3 times x plus 7 to the third power times x minus 11 squared times x minus 7 times x plus 4 to the third power. And I know it's kind of hard to see. I'm hoping you can just zoom your video in a little bit to be able to see what these say. All right, this says list each zero of f according to its multiplicity in the categories below. So they first want the zeros that have multiplicity 1. So that would be any of these binomials where the parentheses was raised to the 1 power. So the x minus 7 is the one that's raised to the 1 power. If I set that equal to 0, I get x equals 7. So the 0 that has multiplicity 1 is 7. Multiplicity 2, that would be the x minus 11, and that's the only one. Set it equal to 0, I get 11 is my 0 there. And then finally multiplicity 3 would be the x plus 7, and then also the x plus 4. So in each case, I'll set them equal to 0 to find out what the actual 0 is. So I get negative 7 and negative 4 are 2 zeros that have multiplicity 3. Question 8 says, find a polynomial function of degree 5 that has the following zeros. And they tell us that negative 4 is a 0, and its multiplicity is 2, and then negative 6, 7, and 2 are also all zeros. Now the good news is they want us to leave it in factored form. That's going to make it easier. That means at the end we do not have to multiply all this out. Okay, so how would I do this? So if these are each zeros, then the way I would write it would be x minus the 0, in this case -4, so that's 1. Multiplicity 2 means that's going to be squared, and then I have an x minus -6, and then I have an x minus 7 and an x minus 2. So I can clean these up a little because a minus next to a minus would give me x plus 4 squared, x plus 6 squared, x minus 7, x minus 2. They wanted this as a function, so I'm going to go f of x equals, and that's the answer. So this, oh, I'm sorry. I should not have put that 2 there. That was not a multiplicity. So that's the answer. So this is a pretty easy problem. Hopefully you'll find it pretty straightforward and you'll be able to get it right on the test. The good news, like I said, is that they're not making you multiply all this out in the end. They said leave it in factored form. This is factored form because I have a list of factors, a list of things that are being multiplied by each other, but I'm not going to do the multiplication. All right, question 9 says choose the end behavior of the following functions. So when they're talking about the end behavior, they're talking about on a graph, you know, how's it going to look? Like, is it going to go? So let's take a couple simple examples. So if I had a line whose slope was negative, as I go to the left, I go up, to the right, I go down. I could have a line that goes this way, so to the left, I'm going down, to the right, I'm going up. I could have something where both tails are going up, or I could have both tails going down. So the way I determine the end behavior is by looking at the leading coefficient. And just keep in mind that it doesn't always mean it's the first term. In fact, what I meant before was we look at the leading term. But if they've written it in descending order, then it is that first term. It's always the term with the highest power. So pay attention to whether or not they've written those in descending order or not. And if they have not, then choose the term that has the highest degree, the highest power. Okay, so for A, if my leading term is -3x to the third power, so the odd power, the odd degree, tells me that my tails will go in opposite directions. So I'm either going to have this one or this one. Here they go in the same direction, right? This is opposite directions. And then the negative tells me it's going to be in the direction of like a typical negative slope. So this is going to be up to the left, down to the right, and it'll do some kind of squiggly in the middle. So up to the left, down to the right. All right, B, my leading term is 6x to the 6th power. So this is degree 6, which is even, so I'm going to have one of these two. The fact that this is positive means it's going to go up. So both of these are going to go up. It'll do something in the middle, but I don't really care. All I care about is what's happening on the two ends. And then C is a little bit tricky because we don't know what the leading term is because it's still in factored form. We would need to multiply all this out to get it into the formats that we have for A and B. But you don't really need to multiply all of it out. What you can do is just multiply these 3 leading terms and see what you get. So 5 times 3 is 15, x to the 2 times x is x to the 4. So that would be my leading term if I was to multiply everything out. So again, I have an even power, so I'm looking at one of these two. This is positive, so I'm looking at this one. So my tails are gonna both go up and something's gonna happen in the middle that I'm not sure about, okay? So this is if I had, let me just state this. These two would be if I had odd degrees, odd powers, right? These would be even degrees. Okay, this is positive leading coefficient, negative. This is negative leading coefficient and positive. Okay, last question for this video is number 10. And 10 says that they want us to match the graphs. So when you do this on Alex, it's going to give you, I think like 6 pictures of graphs to choose from. And so I don't want to draw all those graphs up on the board. So what I'm going to talk to you about is some key characteristics from each of these functions that I would look for when I was choosing my graph. So let's look at this first one. So I've got f of x, I'll rewrite this because it's so small, equals -2 x minus 3 squared times x squared minus 1. So the first thing to think about is, where are my zeros? So I could set this equal to 0, I could set that equal to 0, and in both cases I'll get some zeros. So x minus 3 equals 0, I have x equals 3. Well, what is a 0? A 0 is where the graph touches the x-axis. So I know it's gonna touch it at 3. And something to be aware of is, notice that this multiplicity is multiplicity 2. So if we have an even multiplicity, then it just touches, like it just bounces off the graph. Whereas if it's an odd, then it crosses. So in this case, it's just going to either come down and bounce up that way or come from the bottom and bounce down that way. It's not going to actually cross through the graph. Okay, so let's look at this one. So this one is a little bit more complicated than we're used to. So if I set that equal to 0, I get x squared equals 1, but then I have to take the square root of both sides. And keep in mind, the square root of 1 actually gives me 2 answers, 1 or -1. So that's not a multiplicity because it's not the same answer repeated. It actually gives me 2 separate answers. And what that tells me is that it's going to do something at 1 and it's going to do something at -1. But in each of those cases, they only happen once, right? They don't have a multiplicity. And happening once is the same as an odd number, right, to the 1 power. So it's going to cross in both of these places. So somewhere this will cross, this one's going to bounce or just touch, okay? So what I need to know now is I need to know what that leading term would be. If I multiplied this whole thing out, I would multiply the -2 times the x squared times this x squared. So -2 times x squared would give me -2x to the 4th. So -2x to the 4th, if that had been my leading term, the 4 is even, so my tails are going the same direction. It's negative, so they're both going to go down, right? Which means I would start down. This crosses. It has to turn back around to cross through that. Has to come back to get to that, but that bounces, and then it's going to end down. Both tails are going to end down. So what's important here is that it crosses at -1 and 1. It touches or bounces at 3, and that the tails are both pointing down. And with that information, you can eliminate all but one graph so that you can get to the right answer. So let's look at this other function. So I've got f of x equals 2x to the 3rd plus 6x squared. Now, this one, we can see the leading term is 2x to the 3rd. So what I know about that is, because it's an odd degree, I'm going to have one tail go one way and one tail go the other way. Because it's positive, it's going to, kind of simulate a positive line, a positive slope line. So I'm going to have my left tail going down, my right tail going up. And what about the zeros? Well, I would need to factor this guy. So if I pulled, a 2 can come out of the 2 and 6, and then the most that can come out of the x's would be an x squared. And then what would be left here is x plus 3. So I would have to set the x squared, or you could do the 2x squared equal to 0. and I would just have to set the x plus 3 equal to 0 to find my zeros, right? So here I would divide by 2, I get x squared equals 0. The square root of x, the square root of 0 is still 0. I don't get a positive 0 or a negative 0. So I get 1 0 out of it, and it had a multiplicity of 2. So that's going to be a bounce, or a touch, if you want to talk about it that way. And then here I'll have x equals negative 3, so this is going to be a cross, because that's a single multiplicity. So I know what's happening with this graph is that it's going to bounce at x is 0, and at negative 3 it's going to cross. It's going to start from the left, it's going to be pointing downward. So if it crosses at negative 3, then it's got to come back to bounce off the 0, and it's got to end going up. So that is enough information to select the picture that matches that. All right, and that's it for this video.